Hello and howdy, my fellow mathletes. Root Beer here, looking at question number 7 on our 2018 Manitoba paper. The line 2x plus y minus 12, which is an odd way to write our lines, but that's okay, is equal to 0, intersects the parabola y equals x squared minus 4x plus 9 at points A and B. So immediately I'm just thinking parabola. Okay, we've got some points. One of them's A, one of them's B. They don't seem to specify which is which. If C is the vertex of the parabola, find the area of ABC. Okay, so that's what we're looking for, the area of ABC. Now, until I learn anything more about this particular triangle, I'm trying to come up with ways to figure out the area of a triangle, and it's not always easy. Now, there is a formula. I don't have it memorized, so I probably won't be using it unless I can reprove it to myself. But there's a formula with coordinate geometry where if you know the coordinates of A, B, and C, you can plug them into a formula and figure out the area of ABC. But as I say, I don't remember that, so I'm not going to use it. But if it's something that you notice is coming up on the contests you write, might be something to invest a little time learning or memorizing. Okay? Alright, so we've got our parabola, x squared minus 4x. So I want to find the coordinates of the vertex. It seemed the most natural thing for me to start doing. So x squared minus 4x plus 9. So I'm just going to complete the square. Break the 9 into a 4 and a 5. This is x minus 2 squared, and we've got x minus 2 plus 5. So C is at 2, 5. Alrighty. So what was the line again? 2x plus y minus 11. Not minus 11. I don't know why I said that. It's minus 12, right? Yeah, minus 12. I often find that when I rewatch the videos, that I have said something and written down something completely different. I don't know why my brain and my mouth can't properly communicate. You would think I would have learned, considering I am a teacher, but oh well. In fact, we can just bring everything over to this side. So 2x minus 2x plus 12 is our line. It's in our more comfortable y equals mx plus b form. That's the one that seems to be the most commonly taught. Okay. And it's going to lend itself quite nicely to finding these points of intersection. So I want to find the A and the B, so let the y's be equal. Then minus 2x plus 12 will have to equal x squared minus 4x plus 9. We'll get 0 on this side, x squared, add 2 x's to both sides, so minus 2x. Subtract 12 from both sides, you'll get minus 3. And this factors into minus 3 and plus 1. So x is 3 or minus 1. So let's say A is at minus 1. And then if you plug it back in, minus 1 times minus 2 is 2, plus 12 is 14. And it's not C, it's B, right? C was the vertex. Alright, and then B is going to be at 3. Negative 2 times 3 is negative 6, plus 12 is 6. Okay. So, there we go. We've got A, B, and C. I could try and draw a picture, but I don't really see exactly what that's going to tell me. But sure, let's draw ourselves a little bit of a picture. So we'll say minus 1, and then 1, and then 2, and then 3 here. And we'll go up to about here for 5. So here for 6. And then all the way up here for 14. And making sure C is our vertex there. Alright, now, because quite often they don't give us just any old triangle, I mean, it's a math contest, I'm willing to suspect that it's a right angle here. Now the question is, how would I show it's a right angle, and if it is, how could I use this information? And by no means is it guaranteed to be a right angle. This is question 7. It should be a little on the harder side. Obviously 9, 10, 8, 9, and 10 should be a little harder, but no, this is in the latter half of the contest, so it is entirely possible that this is not a right angle triangle, but my gut instinct from years of practicing contests, doing contests, tells me this is probably right angled. Okay, so how would I show that? What could I do if that is in fact my sincere belief based on my sketch? Because I got to show my work here. Well, I could figure out the line from A to C. Oh, well, actually, to show it's a right angle, you just need to show that slopes are negative reciprocals. So we could say it has a slope of, so the difference in the y's divided by the difference in the x's. So minus 1, minus 2. So this will be 9 over negative 3. So this will be negative 3. And the line BC has a slope equal to we'll have minus 5 over minus 2 again. So the y-coordinate of B was 6 and the x-coordinate was 3. So we'll have 1 over 1, which is a slope of 1. So not negative reciprocals. Darn it. I was really hoping there. Okay, so not right angled. Unless, of course, I screwed up while calculating something, but I really don't think so. The x has to be 3, and then, yeah, minus 6 plus 12 really is 6. So, yeah, okay. So, these slopes aren't going to help me out. Now, I'll erase them in a moment if I don't think they're going to be useful, but, what else could I do? I really don't want to have to try and figure out a formula in terms of the coordinates. So, and none of these are negative reciprocals of the slope of negative 2, so no other right angles are hidden here. It's not like AB is a right angle, or ABC has the right angle at B. So, what to do? Well, this line here to this line here to this line here. What I'm inclined to do is sort of make a little bounding box and figure out the area of this rectangle, whose height I can figure out. So we'll need some new points here. So we'll call them D, E, and F, also right in B. Okay. So instead of doing negative reciprocals, because that didn't work, even though I really wanted it to, I will create this rectangle whose area I'll be able to figure out, because I'll be able to figure out the coordinates of D, E, and F. And then I've got a bunch of right angles in here, so I will have some right angle triangles I can work with. So I'm going to say something to the effect of, let D be at -1, 5, and E will also be of height 5, and it'll be x-coordinate of 3, and F be at 314. Then ADEF bounds ABC as shown. Okay. So, paired up the coordinates just right, so that's good. Okay. Yeah, so minus go. Okay. I was just double checking because I really thought that right angle thing would work at C. So I was just mentally double checking that A and B are also on the parabola and I didn't screw something else up. It's good to double check, especially if you're feeling queasy, like something should have worked and it didn't. And obviously I am, and obviously my numbers are fine, so I'm worrying about nothing and potentially wasting time. So ABCD bounds ABC as shown and is a rectangle. Okay, so AD has a length of 14 minus 5, so 9. DE has a length of, we go from minus 1 to 4, or sorry, minus 1 to 3, which is 4. So ADEF has an area of 36. Great. So triangle ADC has an area equal to 1/2 base, DC, times height, AD. So that will be 1/2. I would probably also label my lengths here. So 9, 4, this one's 3, this is 1, this is also 1, so this is 8. So 1/2, 3 times 9. Triangle CEB has an area of 1/2, 1 times 1. And triangle AFB has an area of 1/2, 4 times 8. So we can see the area of triangle ABC is 36 minus 1/2, 3 times 9, minus 1/2, 1 times 1, minus 1/2, what was the other one? 4 and 8. This actually reminds me of a Euclid paper, I want to say from 2008 or 2009. I feel like there was a similar setup with a parabola and a line, and you ended up having to use a rectangle bounding it and subtracting off some right angle triangles. Anyway, we get 36 minus 27 over 2 minus 1 over 2 minus 16. So that'll be 20 minus 28 over 2. That'll be 20 minus 14. So the answer should be 6. ABC has an area of 6. And that finishes off question 7 because it had no parts. Right? Nothing else we're missing here. Not at all. Okay. So there we go. Question 7. Of course, up next will be question number 8. And please join me for that if you would like to. I'll see you there.